Example number 2 for projectile motion. As you know, you studied that in physics, so this must be a review for you. There is at least 6 other problems that I post. What is the common component is that we do not have acceleration in x direction, and we have only acceleration in y direction, and this acceleration is gravity. So we know that we have constant acceleration, and our acceleration is gravity because of the units that we are using is the international system. We know that our gravity is negative 9.81 meters over second squared. In order to find the horizontal distance, the projectile travels when it's fired from a point A, and we know the velocity and the magnitude of the velocity is known, and also the direction of that velocity is known. So we know that this projectile travels eventually and falls down, and we want to know this distance. That's what we want to find. So we can put our coordinate system right here, x and y. So what we want to find is the x distance. So actually, this distance will coincide with our 0 value for x coordinate system. So if we want to write our equations for x component, we know that our acceleration is equal to 0, and we know our velocity. So the velocity in x is that velocity. We have the angle, so it will be a cosine of that. If we name that angle theta, will be cosine of theta, and the cosine we know that is 4 over 5. So it will be 150 times 4/5. So this is 15 divided by 5, it's 30 times 4, 120 meters over seconds. Then we know that our is the integral, right, of that velocity. That will be x0 plus v(ax) t. And actually we should have added the acceleration for t squared over 2, but we know this term is 0 because we already said that this is the acceleration in y direction, and in x direction our acceleration is 0 meters squared. And since our position is 0, we have then, this is 120 times, and this is actually the time that the system travels in air. So we want to find that position, which is our r, but we have time as an unknown. So let's analyze our y component. In this case, we have a y is equals a sine of theta, which is 150 times 3 over 5, which gives us 90 meters over second. And then we know that y will be equals to the integral of the velocity. But in this case, we do have acceleration. If we don't remember those formulas, don't worry, because you know always that the velocity is the derivative of the position, and the acceleration is the derivative of the velocity. So those are the ones that you have to remember. So if we know that actually I should put the correct way to put it is y equals y0, but this y0 is 0 because we place our coordinate system right there. So the expression that I wrote before was not wrong, but I just wanted to make the point that y0 will be 0 only if we place our coordinate system right there, because we could have pressed it right there or right here. Then we have that our final y, since this distance actually is given, which is 150 meters. So we know our final y will be minus 150 equals 90 t minus 9.81 over 2t squared, that we can solve for t. If you solve the quadratic equation, you can use your calculators to solve the quadratic equation, or you can use the quadratic formula, however you please, that it gives us two results, negative 1.54 seconds, and time is 19 0.89 seconds. Obviously, a negative time doesn't work, so the valid solution is only that one. So that's our flying time, which is our second question. And then we can place that in our first equation that we got, and R will be 120 times 1989, and that gives me that R is equals to 2,387 meters. And that's the distance that the projectile covered. Obviously, this is not in scale because it's only 150 meters and it looks like the same distance, but you can imagine that the projectile went farther away, 2,387 meters.